Welcome everyone. This is the July dev call for 0x. Today we have a kind of a still somewhat of a packed agenda. As many of you know, we launched Matcha just yesterday. I'll give just a couple of updates there. We're going to spend some time detailing the new Exchange proxy architecture that we touched on in the last couple of calls and the first transformers that we are actually implementing in the first iteration of that pipeline. Then we're going to go through an application, a live application through screenshots in Matcha of the RFQt system. If you recall, a couple of calls ago, we talked about a new way of sourcing liquidity in the 0x liquidity funnel. And we're going to give a few updates there. In the meantime, with Alex is in the call and is going to walk us through the updates on Mesh. Specifically, there's a new GraphQL API that he implemented and with the team. And then a quick update on an upcoming vote. And I didn't add it to the agenda, but today we have a special guest poll ecosystem update on Augur. As probably many of you have seen, 3 days ago or 2 days ago, they announced that they're going to launch by end of the month. So we are looking forward to hearing more from Paul directly. All right, let's dive in. I just wanted to make sure that, encourage everyone to basically try out Matcha at this address, Matcha.xyz. I just wanted to reiterate a couple of product design principles that Chris shared last week in a conference. We're working on the video, so we're gonna link it out as soon as it's available. And the link in this slide sends to a Reddit post where there is a summary of those product design principles. But those are basically aligned with the biggest findings that we found as we interviewed people in the DEX space earlier this year, as we were looking at what should we build. And the biggest problems that we found were actually around the fear of interoperability with DEX applications. We found out that many users, no matter their level of expertise, they were always feeling a sort of a reluctance in making actions in these applications because of many things that can go wrong. I mean, prices could have horrific slippage or other things that make their experience unexpected and fearful. So this is the thing that really inspired our product designs, and we wanted to make sure that this is a product that is for everybody, super clear and fun and accommodating, and absolutely without that feeling, communicating that feeling of uncertainty. So that's number one priority for us. The other one thing that we observed and realized was that people really like to learn about new tokens and figure out how they move, their prices, and things like that. So really this token first experience, and that inspired us to really have a sort of a flow where people are able to discover and search for tokens and learn more about them and the characteristics of the markets attached to them. And then the third thing that is listed in that comment, we also wanted to acknowledge that, frankly, we knew that the DEX space was moving fast, and it simply kept on moving faster. So this is a good news, and basically this is going to inspire us to learn more about the reactions of the product and continuously improving it according to these design principles. But yeah, obviously, as many of you know, it's using 0x API behind the scenes. It's actually leveraging meta transaction endpoints that we presented a couple of dev calls ago, and also being served RFQt liquidity. And we're going to detail more about that in the next slides. All right, now back to the 0x core team roadmap. As you can see, there are a bunch of stars here in this roadmap slide. It's been 3 calls, I think, that we use this slide, and it's proving to be very useful to show where we put focus on. And going real quick on the list, we're going to be talking about mostly the first and the third row of this slide. So exchange proxy is being tested right now, and we're working on an on-chain swap function that I'm going to be giving you more details on soon. Stop limit orders are live on Bamboo, as we announced last time. Then RFQt is available in 0x API. Another slide on that later. And we're also working on this WETH unwrapper functionality on the exchange proxy, and I'm going to have a slide on that too. What else? On the 0x API, you're pretty much on top of everything that we shared last times. There's a new component to the RFQ market maker tech stack, which is basically the RFQ server implementation for market makers. That it's live as of now. We have a couple of partners providing liquidity in this way. Then another news in the roadmap that you will see later with Alex is around the GraphQL APIs. Obviously, Matcha is launched now, and we're going to have a new update around the vote on ZEIP 79. So on the exchange proxy, wanted to make sure that you guys knew that the contracts are deployed. We actually gave a very high level overview of what they are, what this exchange proxy architecture is last time, but we also have published specifications that you can review here. And since this exchange proxy, which can be almost interpreted as a trusted extension, is requiring an allowance, we're gonna basically announce a bug bounty by end of the week. That is gonna be pretty much aligned with what you know about bug bounties for 0x. So we're looking at basically making sure that the potential big vulnerabilities are discovered as soon as possible, and we are eager to work with whoever discovers that to make sure that we fix that. We reviewed it extensively internally too, but obviously we need your help to have another pair of eyes, or hopefully even more. So again, if you recall the presentation last time, the overall architecture is an entry point that is unique, and then a set of transformers that are almost Lego of the composability of operations that can be done around settlement. And we have good examples of transformers in the next 3 slides. The plan of this is actually to test out this new architecture with real life examples, and then eventually make this entry point become the canonical entry point, if you want, of the V4 of the protocol. And obviously, for that, there's going to be a governance vote later this year. Let's jump on the very first transformer that I think we briefly described last time. This is a WETH unwrapper transformer. This is basically allows to basically support the functionalities of the forwarder, so wrapping if. So when I'm actually swapping if for a token, I'm able to wrap it. But also, it works also on the other way around. So this is the new addition that we added in this functionality. So basically, that allows for people to swap ERC20s with if without having to receive WETH. Before, that was, I mean, in the classic exchange, that's the route that would have gone. So as you can see from this diagram, what the taker would do as calling exchange proxy would actually hit. It would make sure to basically call also the transform ERC20 function. So the order would work on the same way. So by calling exchange V3 for the classic swap of the tokens, but then there would be this additional unwrapping operation that makes it so that what the taker receives is actually if. So the plan for this is actually to route 0x API to this exchange proxy soon. It's not live yet, but this way, basically, through swap on 0x API, it's going to be possible to have this seamless experience for users that therefore wouldn't make them required to have WETH. Questions around this? no, I'll move to the next. Transformer. This is actually something that I think Joao and Lauren asked about, and it's something that it's not complete yet, but the code on the smart contract level seems to be in a good spot. Here's the PR that was actually merged, not deployed yet, but basically the affiliate fee transformer. This basically allows the taker moment to basically make sure that there's an affiliate fee paid to a third party. Basically, as we go into the exchange proxy, one of the transformers will be actually extract a part of the assets and pass it to the affiliate. As said before, we completed the smart contract code. It's not deployed yet, but shouldn't be too much of an issue. What's going to be necessary to do, though, potentially, is the tooling part. For example, plugging it into Asset Swapper. That is currently not really on the highest priority for ZRX Labs, but I wanted to open kind of a discussion with this group. I know that if Joao is here, I think it'd be interesting to hear his take on whether it would be, for example, interested in helping us out in basically completing the integration, or according to what he needs.
I do.
Pushing this forward.
Can I do a small question? Can we pass like multiple transformers about affiliate, or at the moment it's the implementation only allows one affiliate transformer?
I'm not able to respond. I'm not sure if Amir knows, but
I'm actually not 100%. I haven't reviewed this code, but I'm fairly sure that you can like chain an arbitrary amount of transformers together. So you could probably just do multiple affiliate fee transformers in a single transaction to accomplish that.
Okay, good. So do you guys need help? Which kind of help? It's testing it or actually implementing it? What will be the kind of help you need to implement this?
I think it's mostly the tooling part. If you want how to act, the libraries that are needed basically this part of the exchange are incomplete because we just released the exchange proxy. It's fairly new for us. But while they are done for the WETH unwrapper, they are not done for this specific transformer.
Okay, got it.
Yeah, so primarily the TypeScript code for interacting with these. And I should also add that for these types of things going forward, like if these are features that are valuable for the community, and we might not always have the bandwidth to build them, like we'd be happy to open up community bounties for anyone who's willing to implement them.
But basically, if you already have the smart contract, it's not only create the wrappers, the TypeScript wrappers. This is not done automatically, or I don't understand what is the kind of tooling you are asking. Is because normally I pick the smart contract and only generate the wrappers around it, or is anything else that needs to be done?
I would say like updating ZRX API to be able to support these, as well as Asset Swapper, but it's primarily around designing like a higher level interface for interacting with these, more so than just generating the wrappers. Because you're right that the wrappers can be generated automatically.
Okay, it will be good if a good specification what is pending, and then we can basically do pull requests to close that issues. That at least helped me to know what is pending. To if I saw it, if I can help in the I need these issues are need to complete this task. I can pick one of them and start working on it. So yeah, I'm open for it. Okay.
That would be awesome.
All right.
We just wanted to start a discussion on this call and see if there would be any initial interest in that. But yeah, I think you're right. Yeah, we should probably specify the issues a bit further and go from there.
And the good news is that maybe you can also test directly the wrappers that you're able to generate on your own. So you can test this functionality on your own. And I'm not sure if your use case, I don't think for your products, Joao, you use swap or swap endpoints of 0x API. So potentially you'd be able to integrate them even without that. But it'd be great if you could help us also surfacing this up also up the layer of all our stack.
What I'm doing exactly right now is using directly the smart contracts. It's the same as LaunchKit. So basically what I need now is pass the affiliates to our portals, to them start receive affiliate fees directly from the smart contract. But if it is needed to help in anything else, I think a list of issues that the community can start contribute, I think it will be good because at least we will see where we can help, and then we start working on it. I will
Sounds
say,
good.
oh, Theo, I will start. I saw that I'm able to do this. I can help on this issue and open a pull request, and then you
Awesome.
guys review it. So if that will be that way, I think I can collaborate on that sense. Okay.
Awesome. Thank you. And I think it's also something that we probably didn't do a good enough job so far, and it's something that we want to make sure we give room also for more of you guys to contribute in the stack. All right, I'll move to the next transformer. This is a pretty interesting one. It's basically going to be a transformer. It's actually displayed here. The graph is a little bit different, but I think it explains the flow of operations. We want to distinguish basically the way that we fill native orders. By native, we mean those that are really coming from a 0x order versus the ones that are calculated by 0x API swap just in time to represent the on-chain liquidity. The reason for that is that there's basically a bunch of gas cost savings that we can introduce and also potentially distinguish the way that we charge or not charge protocol fees. So basically what we have in mind is to create this transformer that basically will fill all the on-chain liquidity if you want. So the Uniswap or Kyber liquidity that is basically being swapped by using the swap endpoints in 0x API. These orders then, or this liquidity, will not go through the exchange P3, but will go directly to the bridges, to the Uniswap bridge or Curve bridge and the others. That is going to allow us to do two things, mostly. Again, basically skip a bunch of hop in the contracts pipeline. So that would mean decreasing gas cost. But also what we want to go with in this first iteration is actually completely remove protocol fee for these orders. That is going to benefit all products that are using swap endpoints, because basically means that protocol fee is going to be charged only on the native liquidity and not on the aggregated liquidity. So in examples like when the best price is on Uniswap or in Curve, and there's no counterpart in 0x native, well, we're not going to charge a protocol fee for that. So this is going to be available approximately by end of July. And yeah, it's going to be supported in all the products that use 0x API swap, including Matcha. Are there any questions around this? Because this introduces kind of a different dynamic, I think, in the way that we have been presenting aggregated liquidity. No questions? Right, if you have any later, we can discuss. I wanted to follow up on the RFQ type of liquidity that we quickly presented a couple of months ago. We've been working behind the scenes, and now the product or the type of liquidity is being served in a couple of integrations, including Matcha. So I wanted to show you how it looks like. Last time we went through this graph real quick, but I wanted to make sure to basically outline again how the flow looks like. When an application is utilizing 0x API and the users are in a phase of price discovery, for example, in Matcha, they are quickly changing the pairs and figuring out what the price would be if they fill that quantity of a token. They are basically pinging, they're utilizing the swap price endpoint that basically is forwarded from 0x API to the market maker directly that responds with the price. And this is returned to the user. These are non-binding quotes, meaning the user is simply exploring and looking around, and the market maker is basically returning back the best price. Something that is not displayed here is the fact that 0x API anyway returns to the user the best price, not only from this market maker, but also from Uniswap or Mesh Liquidity or Kyber. So it's important to note that what's returned in 4 is always a combination of the best prices. When the user is ready to basically fill the order, they send a different type of request when there is a specific parameter that is called intent to fill, and that is equal true. And this request arrives to the market maker that knows that this is a binding quote. So they respond with the signed order back to the user, and the user is able to basically submit the transaction. It's interesting also that what's being returned in 7 and 8 is an order that has the taker address field filled with the taker address here. So there's also the security at the market maker side that only that user can actually fill that order. So if you're curious to see it live, a couple of screenshots. You just open your developer tool and you'll be able to see price explorations directly. So here is a screenshot from Matcha. I'm basically looking for a price, and this is being returned by 0x, but it's actually a RFQ provider. And as I go through the funnel in Matcha and I basically open MetaMask, well, then the call basically to the market maker is the binding quote. So it's a quote with intent to fill equal true, and the market maker responds with the signed order to the user, and then the user submits. If you're interested, Blake presented this a couple of months ago. We're still working actively into integrations. So if you are working on a DEX product that would benefit from this liquidity, reach out to Blake. If you're a market maker that is interested in providing liquidity in such a way, reach out to Blake. And reach out to Blake also if you're a user of an app where you would like this sort of liquidity being surfaced. I think you guys appreciate the fact that this liquidity is, since it's generated just in time, it's potentially much better than an open order book liquidity that sits there for maybe a couple of minutes and prices can move, or of an on-chain liquidity source. This is really a personalized quote for the user generated at the moment. So it's pretty exciting to see it live. Questions here? Nope. All right, moving on. All right, this is for Alex.
Hey everyone, so I've already spoken in one-on-one meetings with a couple people, a couple key users about this, but for Mesh version 10, which is coming up in the early part of Q3, we're planning to introduce a new API for querying orders. This solves a common pain point that a lot of people have been mentioning, and something that we were never 100% comfortable with, which is the existing RPC API for Mesh doesn't really have any support for querying or sorting or filtering the orders. You kind of get all the orders, which is not what a lot of people are interested in. There are a couple key benefits for designing this new API. Like I mentioned, it will improve the queryability of Mesh and make it easier to use for a variety of use cases. Eventually, it's our goal that this API will be the one-stop shop for getting orders from Mesh, and that will allow us to unify and simplify our tooling instead of having to work with SRA and the Mesh.json RPC API and Mesh in the browser, which is slightly different. We just have one API that works everywhere. The path to get there is still something we're discussing because, of course, we don't want to make things harder on people that are currently integrated with SRA or with the existing API. So we want to have a clear upgrade path that makes things easy for everybody. It will also allow us to have better documentation and support for more languages. All the documentation for the existing API is written by hand. It's not really auto-generated, so that means you have to keep it up to date for new releases. Also, all the clients are written by hand, and it makes it hard for us to support every possible language. For the RPC API, mostly we just support TypeScript and Go. Can we go to the next slide? So today we released a draft specification for the new API. We'd love to hear your feedback about this. We are planning to use GraphQL for the API, and I've provided a little bit of reasoning and some background information for why we want to go this route. But we really want to hear your feedback here and make a decision based on what's best for our users. So let us know. We also have released a playground environment where you can go and play around with the new API. You run in your browser, it features autocomplete and hover text and a bunch of nice features. And the playground uses mock data, so it's not connected to the real network yet, but it'll give you a good sense of what the API will look like. Finally, if you have any other questions or comments, you can reach out to us on the Mesh channel and Discord, as always. So, thanks, guys.
Thanks, Alex. This is very cool. So definitely encourage you to have a look at the specs and play around with the interface. Any questions on this? No? All right. So a quick update.
No question,
that's
I'm going to say that I'm excited about it.
Okay, good. Thanks, Paul. Yeah, a quick update on an upcoming vote. It should start actually this upcoming weekend. ZEIP has been around for a couple of weeks now. It's about decreasing the protocol fee multiplier from 150,000 to 70,000. That means basically cutting protocol fees in half for native orders. As you recall from the previous slides, we're actually gonna provide an entry point for on-chain orders where there's no protocol fee charged. So encourage all of you to read the ZEIP and vote during the next time window. It's actually next epoch. A couple of let's say points around the context of this ZEIP. The main driver of this is actually the network conditions that have changed quite dramatically since last year. Last year is when we actually conceived the staking system, the protocol fees, and the protocol fee multiplier was set, actually more than a year ago. And gas prices were very different. So that was actually the very first driver that basically led us to propose this change. The good news is that this parameter is a parameter of the staking system that can be upgraded quite easily in the same way that we decrease the staking epochs. So it's the same sort of actions that is required once the ZEIP is voted on, provided that it passes. Any questions around this? No. All right. So I think well, yeah, we should have enough time for Paul to walk us through Augur v2.
Sure. Can you all see me?
Let me see. I should stop presenting probably. Okay.
Yeah. Now here's the question: am I going to be able to present? Right. Welcome to the cruel world. So for everybody that doesn't know me, I haven't been on any of these calls before, but my name's Paul. I'm the whatever title you want to give me at Augur, the person that makes sure the developers do what they're supposed to do. I also have written quite a bit of code, yeah. So we've been working for the past 2 years on Augur v2. It includes a lot of deep improvements, and probably the biggest one from a UX perspective is a combination of a complete rewrite of how we handle syncing of the system, so that users can see markets immediately, interact with markets quickly, and secondly is the interaction with 0x order books for off-chain order books. This is particularly important in the Augur case because if you look at the current way that betting systems operate, there is actually quite a lot of close to event liquidity that happens. And that is just completely unworkable on any sort of system where you are doing on-chain order books. So even if we were able to scale on-chain order books up, 2 orders of magnitude, we still would not be able to hit the targets for liquidity across the system. So we chose 0x and we chose this kind of mesh system because we saw that the work that you guys are doing is really great. And so we've been working for a while now, about a year, on integrating 0x. And approximately 2 weeks ago, Alex Brown and Toli pushed some patches, and now we're good to go. So I'll open up a screen share here if I can, and then I'll show you just guys how it all works. Should be pretty exciting. It's taking a second. Okay, are you guys able to see my screen? Okay.
Yes.
So this is a brand new deployment of Augur v2 on Kovan. So there's not very many markets yet, but this is kind of where we're doing all of our testing. I'll just give you the very brief walkthrough. It looks like any other trading platform. There is a list of markets that you can trade on. These are formulated as prediction markets. Each market can have between 3 and 9 outcomes. There's always an invalid outcome, which means that each market has 3 to 9 order books. And those order books are presented in the interface so that a user can choose which of these outcomes they want to bet on. And we manage all of that with 0x order books. I'll also say that we do some very weird, complicated things with the way we interact with 0x in order to make this work. So it's an interesting, deep topic if anybody wants to go into the details there, and I can answer some questions, but we can look at it. So I'm just going to choose, actually, the first thing I'm going to do is log in so that I can get some ETH into this account. Thing about Augur is v2 is that it's DAI first. So everybody that we integrated, and now of course I'm doing a demo, I'm not going to be able to log in. Sorry about that. Let me refresh here. Like I said, brand new deploy. So one very important thing about Augur is that v2 is that we're DAI first. So any of the markets that you see are denominated in DAI. So let's just go to a market here. So when you go to this market, you can see that it looks sort of like you'd expect. There is, an order ticket on your left. This is where you can buy and sell shares. These are the various outcomes. These show different order books. So you'll see that each one of these is indeed its own separate order book, including invalid. This is an important feature for anybody following Augur v1. Having the ability of users to actually price in invalid into the risk of the market was very important. So that is included in here. But the interesting part with 0x, as you can see here, is we actually are grabbing orders from the 0x order books, but this is 0x mesh. So everything that we're doing here is synced in browser in this client's computer. What this means is that for Augur v2, there's like zero hosted infrastructure. Outside of like the routing nodes and things that 0x provides, the routing nodes that IPFS provides, those sorts of kind of like infrastructure pieces. This can be run on anybody's computer and it will sync using 0x mesh in browser. So these are just standard orders. Users can click on them, and if they were logged in, we'll fill up the order ticket. But let's see if I can get logged in now. Let's see if I can get logged in. There we are. Well, geez, now I can't log in. I'm sorry, I can't actually show you this working. But I'll get it fixed right after. So the idea here is that, so these are complete 0x order books. One thing that I'll note with how we've done this is that I believe currently on mainnet with 0x mesh, there's been around 4,000 to 5,000 orders that have been kind of living there across all of the infrastructure pieces. We've tested this UI with above 11,000 orders. One of the things that we're expecting is that this could handle, pretty extremely high volumes. So this means that a client on an iPhone can load the UI, can receive and validate 11,000 orders without impacting the UX of their iPhone. So we think that that's pretty good. That's a pretty good starting point. It took a lot of work on the part of the mesh team, and I'm very grateful for all the help that you guys have provided throughout that. And I do think what this shows is that we can build very, extremely fast, competent apps without needing to rely upon, centralized hosted architecture. It is difficult. It did take us a lot longer than it would have taken to do it any other way. But with these infrastructure pieces that we have in place that you guys have built, we were able to pull this off. And I'm pretty grateful about that. Does anybody have any questions or thoughts about how Augur works or how we integrated with 0x as I try to get my logins working on this new browser?
Paul, can you talk a little bit more about some of the things that you learned from Augur v1 and what led you to design version 2 this way?
Oh, certainly. So the Augur v1 was an interesting experiment. So at the time when we launched v1, there was very little, like truly very little architecture that existed in the ecosystem that was capable of doing much more than just running some, ETH calls. And so what we built for v1 was this whole system where a user would actually need to sync a server on their local computer, and that would keep track of on-chain orders, that would keep track of on-chain markets, and then they would run a UI against that server. That is something we knew would not scale long-term, but at the time there was not a lot of good, there were no good ways to actually really handle it differently. So for v2, we really took a look at this and we thought, hey, what if we are designing this not as a proof of concept, not as nerd first, not as crypto first, but as what a betting experience should be that normal people that already do this expect, right? So everything about this UI is designed as much as possible to hit the expectations of somebody that is already doing these actions on a centralized service, for instance, Predicted. This isn't perfect because there are just some considerations of crypto that we need to deal with. Things like approvals, things like having your account address be a huge long list of hexadecimal digits, those sorts of things. But for the most part, we really tried to hit that. And one of the things that's really key to that, and one of the reasons we went on the path of mesh, is that users do not expect to have to pay to make open orders and to wait for those open orders to hit an order book for 15 to 30 to 45 seconds. That breaks the experience for a general user, and it actually makes automated market making completely impossible. I'll give you an example. So we talked to people that do automated market making for, say, a sport like tennis. The way that a tennis works is they will reprice odds per player every single serve. They'll place thousands of orders per serve and cancel thousands of orders per serve. That sort of ability needs to, in order to do that, you need to be more or less able to move thousands of orders a second. That is not something that you can do with any on-chain solution that we have today, or in the foreseeable future, really. So that sort of thing made us look and say, like, hey, what do we have to do this? Now, there were some things that we saw out there that are able to handle data loads of that size, and these are peer-to-peer networks. If you look at the amount of data that, like, the ETH peer-to-peer network moves, or the Bitcoin peer-to-peer network, or BitTorrent, any of these, they're able to actually move lots of data very quickly, and so it starts to make sense for that portion of the market making experience. The ability for a market maker to keep as many of their expectations as possible, and the ability of a user to keep as many of their expectations as possible. I'll say that where we're at right now, it's not 100% perfect. And that is for two main reasons. One is that with the 0x mesh system, as with all 0x orders, cancels have to be on chain. And that is a fact of life. So that is one thing that users would not normally expect. Another thing that users don't normally expect that we've had to deal with in designing V2 is the fact that in a peer-to-peer system, there's no actual consistent state of an order book. That is also confusing, and that's something we've had to deal with on a UX perspective. So if you look here, these are the orders we show you based upon what my browser the view my browser currently has of a peer-to-peer network. And in V1, this was very easy. This was an ETH call, get me all the orders. In V2, this is a kind of an ever-shifting landscape. And so there's some interesting things that we do here to try to provide users with a good experience. For instance, if an order is going to expire, because mesh orders have a timestamp just like all 0x orders, if an order is going to expire faster than that user can get an order in a block, we won't even display it, for instance. Another example of this is, say I try to take these 100 shares. Say I want to take 10 of these shares, and there's 5 orders that make up this 100 shares on this buy order here. We actually pass in multiple orders into the contracts so that our system, when it's taking the orders, will attempt to match as many shares as possible, even if some of those orders have been filled or partially filled. So there's a lot of little details that went into making this kind of try to match expectations, even if it's not 100% perfect. So we do think that where we're at now, it matches expectations good enough that for the normal user, it will work as expected. So that's a big one. I'll say, like, just getting order books fast enough from V1 is huge. And then where we're going to be going down the line is the next big thing, which is on-chain fills are still too slow. So we're going to be looking at building on top of the 0x RFQm model, which is a slightly different variant of the RFQt model that Theo presented today, where the maker is able to actually take the have last look at the order. And we're looking at integrating with Matic for fast actual trading fills. So with these three components, with RFQm for market makers to be able to cancel, basically, with 0x for order books to be able to move and change rapidly, and with a layer 2 solution, Matic, Arbitrum, whichever one wins at building support, we'll be able to have fast fills. And this is kind of the, that's the spot you need to be in to really support the high levels of liquidity that happen on centralized betting exchanges today.
What is the?
It's pretty clear. Sorry. Go ahead, Amir.
Oh yeah, I just wanted to ask what rough gas cost of filling an Augur order is. I know probably 2 years ago it wasn't really a problem, but gas costs these days can add up.
Yeah, I was just me and Augur Alex, I'll call him because you guys have two Alexes at 0x. We've been talking about this a lot. So currently, the basically 1 million gas per order, which is terrible, I will say. It's currently very expensive to fill trades on Augur. This is another reason why moving to a layer 2 solution becomes super necessary, simply because the fixed cost of orders pushes up the necessary order size in order to make a profit. So if gas costs stay at 60 gwei, you're looking at $18 trades. So it doesn't really work. So we're looking at that, and we're actively working on seeing what we can do there. But just because of all the bookkeeping that's necessary and the complexity of what happens in Augur trades, the cost is still very high.
Do you think using an RFQ model, you would be able to simplify some of that logic potentially and reduce gas costs?
Unfortunately, no, because most of the logic, the actual order matching logic, is, sorry, not the order matching logic, the order filling logic is quite complicated. And this is because of the way that Augur markets work. So for instance, I can come here and if you look at this, I have 0 position in this market. I'm actually able to come to this and I'm able to short the Jacksonville Jaguars in this case. I could sell 100 shares at 0. Whatever I want to do here, 35, I could actually sell, my account isn't logged in, so I don't have DAI, but I could sell shares I don't have. And what this actually will do on the back end is give me shares at an average price that's the inverse of what I'm offering here of all of the other outcomes, including invalid. So there's a lot of logic that goes into creating these kind of synthetic short positions. There's a lot of logic around calculating around some other things that we wanted to be able to provide, like on-chain profit and loss calculations that make the overall user experience good, but the cost of filling the orders just very high. Now, one thing that would potentially help is that in an RFQL model, we know that order will be filled. So there's a little bit less logic, but for the most part, the cost is still there in all of the storage updates.
Makes sense. Well, yeah, thank you for the presentation. It's super, super useful.
Yeah. And I'll note, if anybody wants to come into Discord and ask us any questions or go through it, look at our code, super willing to spend some time with everybody. I'm hoping that what we learned here is useful to everybody else.
Thanks, Paul. Yeah, it's pretty, well, we all appreciate the challenges that you faced in order to basically get to the same level of centralized betting experiences. It's very complex to replicate that in the Ethereum, in the Ethereum world, or like in decentralized world.
Right, and now we're going to have to be the first people to layer 2 as well, even though we've got the most complicated use case on the planet.
Yeah, looking forward to seeing how you solve that. I want to, well, we're almost kind of done with time. I seen a question only now. When I was presenting before, I couldn't see it, by David. Exchange proxy is not compatible with ERC 7021 as of now. So you should still use the forwarder. I'm not sure if you're still in the call. I'll make sure that I also ping you in case you're still, if you're not there. Are there any other questions? All right. Cool. I think we can close it here then. Well, thanks a lot for joining. We used the full hour, so very interesting update from Augur. I think it took really more time than expected for good reasons. So very happy that we were able to dig deeper into that. So thanks a lot, guys. We'll post the recording soon. And oh, Paul. Sorry, you. Okay. Yeah, obviously. Yeah, so we'll post the recording soon, and tune into the next call for more updates. If you have any questions, as always, post in our channels or directly in the GitHub repo with the recordings and the slides. All right. Thanks a lot, everybody.